This is a frequently asked question video for pre-calculus for the first day that we're working on the Chapter 7 review. And number 17 is an example where you really need to read the directions carefully about what you're supposed to do with the matrix. In this case, it says find a row echelon form for the matrix. That does not say reduced row echelon form. It says row echelon. What that means is we want ones across this main diagonal right here, and we want zeros in those positions that are to the left of it and below it. To do that, we do row operations. So let's take a look at what we can do with this. My first thought is I like this 1 up here, but I have to get rid of that 2. And the way to do that would be to take -2 times row 1 and add it to row 2 and see what we get. So I'm going to keep row 1 exactly the way it is, but now I'm going to take -2 times 1, which is -2, plus 2, and that gives me 0, which is great because that's what I wanted to happen. I wanted a 0 in that spot. Now I have to take 2 times -2, which is -4, and -4 plus 1 is -3. Then I have to take -2 times 1, which will give me 2, and 2 plus 4 is 6. While I'm at it, I might as well get to work on row 3 as well. In order to get rid of that -3 and to make it a 0, I'm going to have to take 3 times row 1 plus row 3. So back at it again with row 1. 1 times 3 is 3. 3 plus -3 is 0. That's exactly what I wanted to happen. 3 times 2 is 6. 6 plus 0 is 6. 3 times -1 is -3 plus 1 is -2. Now it's starting to look a little closer to what I need. And I notice that row 2 could definitely be helpful at getting rid of row 3 for me at that point, at least getting rid of that 6 for me. So I'm going to leave my 1, 2, -1 alone. And I'm going to leave my 0, -3, and 6 alone for just a minute. And what I'm going to do is take 2 times row 2 and add it to row 3. So 2 times 0 is 0, plus 0 is 0. That hasn't affected my zeros that I need there at all. 2 times -3 is -6, plus 6 is 0. That's what I wanted to happen. 2 times 6 is 12. 12 plus -2 is 10. Well, 10's not exactly what I was hoping for, but now I can take some scalar multiples of each of these rows and I can get it to what I need. So what I want to do is leave that top row alone, but the second row, I want a 1 where this -3 is. So I'm going to multiply that second row by a -1/3. That will give me 0, 1, and -2. And I'm going to take row 3 times 1/10, because that will turn this into 0, 0, and 1. And that is a row echelon form. I have 1s across the main diagonal and 0s for everything down and to the left. So my matrix of 1, 2, -1, 0, 1, -2, 0, 0, 1 would be the answer that I need. Now that's definitely not the only way to write the row echelon form for this matrix, but I think that's pretty easy to follow and should get you where you need to go. Then number 20, well, this one says the same thing. We're going to find a row echelon form. But the thing is, this is not a square matrix. It doesn't have to be a square matrix, but what we're going to have to do is get this matrix to have a 1, a 0, and a 1. This is what we have to have in that left-hand corner in order for this to be in row echelon form. So let's see what we have. 3, 6, 9, -6, 2, 5, 5, -3. Two ways to go with this. The first thing I thought of was across the top there, all of those easily divisible by 3. I mean, we could take 1/3 times everything in that row, and that would give us a 1 in that first position. So we could definitely do that. Other things we could do. Well, we could try and get rid of the 2 right away by figuring out how to use the matrix row operations to get that to happen. And there's a lot of different things that we could do. But what I'm going to do is I've decided I'm going to get 1s in that first position for that first row. So I'm going to take 1/3 of row 1. And that will give me 1, 2, 3. and -2. So now I at least have that 1 in position the way that I wanted to have it. And then we have 2, 5, 5, -3. All right, so now if I take -2 times row 1 and add it to row 2, I will get a 0 in the second row, first position. So second row, first column. So we have 1 times -2 plus 2 is 0. 2 times -2 is -4 plus 5 is 1. That just got better. That's exactly what we needed. Let's keep going. -2 times 3 is -6 plus 5 is -1. -2 times -2 is 4. 4 plus -3 is 1. And there is a row echelon form of that matrix. Again, not the only one out there, but I think easy to follow as far as getting those numbers of 1s and 0s where we need them.